Hello everyone. So today we are taking up the chapter chemical equations, wherein we are going to study about the various types of equation, and before that we are going to study about what a chemical equation is, right? So moving on further with the chapter, first of all we need to understand what a chemical reaction is. A chemical reaction takes place when we observe a new substance that is being formed. The original substances that are participating or that were there before the reaction or before combination are not there now, and a new substance has been formed. Like in this activity, we are observing that a magnesium ribbon that we had, we are burning that and we are getting some white powder, and also a white flame is produced. So when magnesium ribbon burns with air, in air, it burns with a dazzling white flame and it changes into the white powder. So white powder is something that we didn't have before burning it. So it is a chemical change. So we see certain changes that take place during a reaction or during formation of a new product or during a chemical change. Either there is a change in the state of the substance or in the color, or we can observe the evolution of gas, or change in temperature is also observed. These things were a bit confusing for you. I must tell you that these are the observations for a chemical change. These are not the conditions that whenever this happens a chemical change happens, but yes, it is other way around. Whenever a chemical change happens, there will be a change in either the state or the color of the substance, or there will be a change in temperature, or there will be an evolution of gas. For example, we are taking change in state. It can be changed through physical processes also, right? Like if you freeze water, it turns into ice, and if you boil water, it turns into vapors. But chemically, water remains same. It is not forming any new substance. So change of state is there, but chemical change is not there. Change in temperature happens when we warm up milk or water, right? So there is a change in temperature, but new substance is not formed. So when there is a change in temperature due to the formation of new substance, then only we say that a chemical reaction takes place, right? Now coming to representation of these chemical changes. How do we represent it? Like when we burn magnesium ribbon in air, air means oxygen, right? So whenever anything is burnt, it means it is reacting with oxygen. So white powder is formed. So we can say that the white powder was of magnesium oxide. So when we need to write it, we are not going to write so much every time. So we need to give it a form. That form is called chemical equation. The equations may be of two types: the word equation and the chemical equation, wherein the chemical formulae are used. A word equation defines the reaction through the reactants and the products names, right? Like where we are using magnesium, so we write magnesium plus oxygen, and that gives, so we put an arrow for that, and we get magnesium oxide, so we write magnesium oxide. We are not using formulae anywhere. For a chemical equation we need the formulae. So for a magnesium we need Mg, we put a plus sign in between. Then for oxygen we write O2, put an arrow, and for magnesium oxide we write MgO. So this is a chemical equation. Taking another example where we are adding zinc to sulfuric acid, the word equation will be given as zinc plus sulfuric acid, where we get zinc sulfate and hydrogen. Symbolically we represent it as a symbol of zinc. Zn plus H2SO4 gives ZnSO4 plus H2. Now this equation has to be balanced, so we count the number of atoms on both the sides of the arrow. So arrow is kind of a balancing thing, and we calculate the number of atoms of the reactants. That means the symbols before the arrow and the symbols after the arrow separately. Now these two symbol and their atoms should be same on both sides. If zinc is one on one side, then zinc should be one on the other side also. If they are not balanced, then we need to balance it manually. Yes, please consider like this is the manual thing that we are writing. Actually, when we are going for the reactions, we add up the amount or the product, we get the product of the amount that will be reacting with the substance automatically. We are not going to add two hydrogen, or we are balancing it after adding the substances, right? So it goes automatically, and same thing we get when we balance the equations manually. ठीक है, तो ऐसा नहीं होता कि जब हम उसको हम रिएक्शन कर रहे हैं, वी आर पुटिंग इन जिंक टू HCl, तो हम जिंक के एटम्स काउंट करके डाल रहे हैं. वी आर पुटिंग इन जिंक रैंडमली इन HCl, एंड इन हायर स्टडीज़ वो मोल्स काउंट होते हैं, एंड अकॉर्डिंगली द रिएक्शन टेक्स प्लेस. सो उतना ही अमाउंट ऑफ हाइड्रोजन रिलीज होगी जितना जिंक HCl के साथ या H2SO4 के साथ रिएक्ट करेगा. ठीक है, सो दैट इज ऑटोमेटिकली बैलेंस्ड. But here we are writing manually, so we need to balance the equation manually. So after balancing, we need to write the states of the substances that are used or that are formed. So we show their state as gaseous, that means they are in gaseous state. If they are solid, we write S. If they are liquid, we write L. And if they are dissolved in water, we write aqueous, AQ. In brackets, towards the lower side, right side, lower down. And we also write down the conditions over the arrow, like how much temperature is needed, are they being heated, or if sunlight is required, or any other thing, or some catalyst is required. So any of the conditions are not written along with the reactants, the conditions are shown over the arrow. Okay, so now our chemical equation is complete. Next we have an activity where calcium oxide is being added to water. We see the bubbles, and that means there is an evolution of gas, that means some reaction is taking place. So calcium oxide reacts vigorously with water to produce slakine, that is calcium hydroxide, and it releases large amount of heat. So anywhere the heat is released, we call it an exothermic reaction, and you can actually feel the jar or the beaker hot. So it becomes warm or hot depending upon how vigorous the reaction is. Okay, and this is also called combination reaction because two small molecules are reacting to get a bigger one. Okay, so two things are combining to form a general or a single thing or single substance. So this is a combination reaction. At times you are asked, why does the shine is observed after 2 or 3 days after whitewashing? So the explanation is given in your NCERT, and it is and you need to know the reaction also. What happens is, we are using calcium hydroxide for whitewashing. Okay, so wherever it is being used, it reacts with carbon dioxide that is present in the atmosphere. So it forms calcium carbonate. This calcium carbonate layer gives it a shiny finish. Okay, so because this reaction takes time, it is not an instant reaction, it takes time, it is a gradual process, it is a slow process. So the changes are observed after 2 or 3 days. Further, you are given More examples of combination reaction. The most common reaction is burning of paper, burning of coal, where the carbon is reacting with oxygen and producing carbon dioxide. Here two reactants are there, that means two things are combining to form a single product. Formation of water from hydrogen and oxygen gas. So when two or more substance can be element or compound. Okay, they combine to form a single product. These reactions are called combination reaction, and mostly these reactions produce heat and it makes the mixture warm. So these are called the exothermic reaction. We have commonly observed in burning of a candle or paper or anything else, lot of heat is evolved. So this is a good example of exothermic reaction. Next, we are observing an equation where a single product is being decomposed or being divided into smaller molecules. So such kind of reaction is called decomposition, where the bigger molecule is broken down into the smaller ones. So a single reactant is there and we have multiple products. So such kind of reaction is called, what is it called? Yes, it is called the decomposition reaction. Another equation you have been given of limestone. You might have heard that lime, calcium oxide or quicklime, when reacts with, we have just recently done it, and the carbon dioxide turns lime water milky. So all these equations, out of these equations, when we take off the calcium carbonate being decomposed, so it is a decomposition reaction. Further, there is another equation given wherein the lead nitrate is broken down and brown fumes of nitrogen dioxide are observed. So whatever you are reading in your textbook, please read it carefully. What is being given, the color and the product and the reactants, exactly what and how they are given. So these things are heated to decomposed. So where heat is provided to break down the particular molecule, this is called the thermal decomposition. Therma means heat, so it is called thermal decomposition. Next we have a decomposition reaction where the water is broken down into oxygen and hydrogen through electrolysis. So this is called electrolytic decomposition, where electricity is used to break down the molecule into its constituents. There is another type of decomposition which takes place in presence of light only. So the more reactant or more reactive substances, the easier will be to break it down. Like we have silver chloride or silver bromide, which break down in presence of light only. So this is called photolytic decomposition, and this is the reason why these two substances are stored in dark bottles. You can be asked why silver chloride or silver bromide are stored in dark colored bottles. So you will be giving this reason only, because they react instantly in presence of light and it breaks down into silver and chlorine or silver or bromine. So this is the photolytic decomposition. Next we have been given a comparison where the color of the iron nail is changed and the color of the solution in the test tube is also changed. The reason for this is there is a reaction going on where a substance has displaced, that means shifted it from its place and taken its position in the solution. So there was a solution of copper sulfate and the iron nail was put into it. Later, after some time, we observed that the brown color was there over the iron nail and the blue color of the copper sulfate has faded down. So this reaction can be written as the iron that was taken in solid form, the ionyl was solid, and CuSO4, the calcium sulfate, was in aqueous form because calcium sulfate was dissolved in water. After some time it was observed that the color was changed. So if the color was changed, that means some reaction has taken place. So ferrous sulfate has been formed and copper was displaced. So copper was removed from its position and the iron has taken its position. Two more examples of the displacement reactions are given to you. Please go through all the reactions given in your text and all the color changes or the observations that have been given to you. Next we observe a reaction where sodium sulfate is there, barium chloride is there, but if you observe the substances after the arrow, we see that the sulfate part is taken up by the barium and the chloride part is taken up by sodium. So they have exchanged their position. No one has been pushed out of its place. So they have, when the exchange is there, we call it double displacement reaction. So a white precipitate of BaSO4 is formed by the reaction of sulfate ion and barium ion. The other product formed is sodium chloride. We know that the sodium chloride is soluble in water and the barium sulfate is not soluble in water. It is so it is observed as a semi-solid floating in the solution, and we call it a precipitate. So a white precipitate of barium sulfate is formed. You can be given this reaction and asked what is the white precipitate that is formed. So you will write it is barium sulfate. You can also be asked what do you observe out of this reaction. So we observe a white precipitate of barium sulfate out of this reaction. Moving further with another kind of reaction, the redox reaction. Redox is actually not specific type of reaction. It happens in every reaction that is taking place. Like in the first equation, copper with oxygen when heated gives copper oxide. So it is a combination reaction, but reduction and oxidation is taking place. So one substance is oxidized. Here the copper is oxidized to copper oxide. And what does oxidation means? Oxidation means simply when oxygen is being added to any particular substance. Okay, so if hydrogen is gaining in the reaction that is there, so we see hydrogen is gaining oxygen, so it is oxidized, and copper is losing oxygen, so it is reduced. So simply when oxygen is lost, we call it reduction, and when oxygen is gained, we call it oxidation. There is another way to define oxidation and reduction, and in higher classes you will learn about gaining or losing electrons. Okay, so there it is a higher class concept. I am not taking it right now, but where oxidation and reduction are going simultaneously, we called it a redox reaction, reduction and oxidation, sorry. So we can define oxidation as gaining of oxygen or losing of hydrogen. Okay, so similarly for reduction we can observe whether a substance is losing oxygen or gaining hydrogen. So if oxygen is lost or hydrogen is gained, any of the two is there, then reduction is taking place. If oxygen is gained or hydrogen is lost, then oxidation is taking place. Please don't get confused between two things. Okay, in oxidation oxygen is being added or hydrogen is being released. Okay, and in reduction hydrogen is being added or oxygen is being released. Coming to the last part of the chapter, corrosion and rancidity. Corrosion we define or we understand in terms of destruction of the metals. So we have observed the brown powder on iron iron articles. So that is the rust that is being formed, and it gradually destroys the particular article. The strength that original iron is is having, the rust obviously cannot give that particular strength, so it is released or it is dusted out in the form of powder. Also, we can observe some copper utensils or copper products as over green covering over it, or a black covering over the silver products. These are all the examples of corrosion. You should be thorough with the color and the metal that are linked. Okay, the copper, when corroded, the layer is green. Silver, when corroded, the layer is black. Iron, when corroded, the layer is reddish brown. Coming down to rancidity, rancidity is basically the change in color or smell of the oils that we observe. You might have observed, if an old tumbler is packed with oil, or the oil is finished and the tumbler is packed, because it is not tidally packed, after some time some smell can be observed out of it. So that is due to the rancidity. Similar things takes place for the edible items also, where the fats are used. So this is due to the oxidation of fat. So how can rancidity be controlled? Rancidity can be controlled by avoiding the oxidation. Either the edible things are packed in vacuumed airtight boxes, or they can be flushed with or packed with antioxidants or the things that avoid oxidation. Okay, that's why the chips packets are the amount of chips are less, and the amount of air, that is not air actually, that is the nitrogen that is flushed into the chips packets. So that is all for this chapter. I will send the balancing equation videos also, and you all please practice all the equations, and please come up with your doubts on my personal window or on group as you feel. Thank you, and take care, stay safe, stay happy.